All. Now I am going to explain about problems on electrical circuits. Okay, first problem. A network has 7 nodes and 5 independent loops. The number of branches in the network is, see here in this first question he is given number of nodes n as 7 and number of independent loops as 5. Okay, we need to calculate number of branches, right? Okay, here the number of loops formula will be b minus n plus 1. B is number of branches, n is number of nodes, okay, and L is loops. Here number of nodes is given, number of loops is given, then branches B is equals to L plus n minus 1, right? L value will be 5, n value will be 7, 5 plus 7 minus 1, you will get 12 minus 1, that is 11 is the first question answer. Okay, next second question. The nodal method of circuit analysis is based upon, okay, nodal analysis means first we need to use KCL, right? By using KCL first we need to calculate node currents, right? So that means branch currents, that means first KCL, after that I is equals to V by R, that is from Ohm's law. That means nodal analysis is equals to KCL and Ohm's law. Option B is correct. Next, third question. For a network of 7 branches and 4 nodes, branches is given and nodes is given, the number of independent loops, okay, already this formula is discussed, right? Number of loops L is equals to B minus n plus 1. B value is 7, n value is 4, that is 7 minus 4 plus 1. Then the answer is 7 plus 1, 8 minus 4, that answer will be 4. Option D is correct. Next, a network has B branches and nodes, okay, B is branches, n is nodes. For this, mesh analysis will be simpler than nodal analysis if n is greater than, this is direct formula, that is B by 2 plus 1. Okay, next, the number of independent loops for a network with n nodes and B branches, okay, that is already we know the formula, right? Number of loops is equals to B minus n plus 1. Okay, next question number 6. See here, capital A is A1 into d square y by dx square plus A2 into y into dy by dx, right? Dy by dx term is multiplied with either x or y, that is a non-linear equation, that is non-linear, first option, differential equation. Okay, option 1. Next, second option B, A1 is d cube y by dx square plus A2 into y is equals to A3. Okay, that is B2 value, here no x term is present with differential equation, that is d cube y by dx cube. Similarly, A2 into y is a constant term again, that means another extra term is not present, that means that is a linear equation. Okay, linear differential equation with the constant coefficients, A1, A2, A3 are the coefficients. Next, third one, A1 into d square y by dx square plus A2x into dy by dx plus A3 x square y. Here dy by dx, sorry, d square y by dx square, dy by dx and y, that means order will be reduces linearly, the right? That means it is a linear homogeneous differential equation. Okay, next, seventh question. The following constitutes a bilateral element. Okay, bilateral element is nothing but the element which will allow current in both the directions or whose properties or characteristics are cannot change with change in voltage and current, right? In case of resistor, that is possible. FET, that is not possible. Vacuum tubes, non-linear device, that is also not possible. Rectifier, diode is also a non-linear device, hence the answer is resistor. Next, Kirchhoff's laws are fail in this case. Okay, Kirchhoff's laws applicable for both linear as well as non-linear, right? Diodes, for diode also it is applicable. Dual networks also applicable, right? Then the answer is distributed parameter networks only. Okay, next question. Ohm's law, KVL and KCL will fails. Okay, Ohm's law, KVL, KCL will fails for higher frequencies only. Okay, next question. The number of mesh equations required is equals to number of mesh equations, that is in graph theory number of mesh equations is equals to number of links. Okay, next, the minimum number of equations required to analyze the circuit. See here in this circuit, first identify the number of nodes and number of branches. Okay, voltage source is not a branch, that is replaced by short circuit. That means number of branches. Okay, branch is nothing but it is connected between two nodes. See here, okay, this is one branch, this is another branch, this capacitor is also another branch. Like this, how many branches we are having? 1 2 3 4 resistors, 3 capacitors. That means 7 branches. Nodes, interconnection of elements, right? This one is a node, this one is another node, this one is another node, this is another node, right? And this one is also another node. That means 1 2 3 4 5. Okay, number of branches will be 7, number of nodes are 5. Then the number of minimum equations required will be b minus n plus 1, right? Number of branches is 7, number of nodes are 5, right? That is 7 minus 5 plus 1, that is 3. Option A is correct. Okay, next, see here, find the equivalent impedance across A and B terminals. Now see here, in this problem, here bridge is balanced. Okay, see here, the product of opposite arms 2 ohm 4 ohm, the product of these two resistors is 8 ohms and the product of these two resistors is 8 ohms. When it is satisfied, bridge is balanced. When bridge is balanced, current flowing through center arm will be 0. That means no current is flowing through parallel combination of J3 ohm and minus J4 ohm, right? Then when no current is flowing through this J3 ohm and minus J4 ohm combination, now this will be eliminated, right? This will be eliminated. When it will be eliminated, 2 ohm and 2 ohm are connected in series, right? Here 2 ohm are connected in series. Again this 4 ohm and 4 ohm are connected in series, right? Then 2 and 2 in series, 2 resistors will be added, right? 2 plus 2 4, again here 4 plus 4 8, 4 in parallel with 8, that is 4 into 8 by 4 plus 8. Okay, if you simplify that equation, you will get the answer is 8 by 3 ohms. Okay, next, problem, find the equivalent resistance between A and B terminals. Now see here, all values are equal. Okay, that means all resistor values are equal. Now from this circuit, okay, assume this node as C, this node as D. Okay, from C node to D node there is a short circuit path, right? This is a short circuit path. Okay, this path will be replaced inside also, right? That means here I can replace this C to D path will be inside, right? Like this. Next, this A terminal can be taken into outside. Similarly, B terminal is also taken into outside. Okay, like this. This is A terminal, this is B terminal, right? This A terminal is having resistance. Now see here, these two resistors are connected in parallel, that is R in parallel with R. Next, these two resistors are connected in parallel, right? R in parallel with R. Two equal values are connected in parallel, R by 2. Next, these two equal values are connected in parallel. Again, resultant value will be R by 2, right? After that, this R by 2 is this resultant value, R by 2 and this R by 2 both are connected in series. Then the resultant value will be R. This R will be connected in series with this R. Then the resultant value will be the equivalent resistance between A and B terminals is 2R. That is option A is correct. Okay, next problem. In this 14th problem, here we need to calculate equivalent resistance between A and B terminals, right? Here I need to calculate equivalent resistance between A and B terminals. See here, first of all identify how many extra junctions are present here. This is C. Okay, this is also same as C. Right, this is D. This is also short circuit path. This is also D. Right, that means this circuit is having total 4 junctions. Okay, this point is clear, right? After that, first of all we need to calculate equivalent resistance between A and B terminals, right? This A terminal is having one resistance, B terminal is having one resistance, right? Okay, that is A2, assume here it is C, here it is D. Okay, this is C, right? This is D, right? Then see here, 15 and 10 are connected in series. Next, this 10 and 40 are connected in series. 15, 10. Wait a minute. Now see here. Here 15 and 20, 10 are connected in series. This 10 and 40 are connected in series. And 20 and 30 are connected in series, right? These two resistors are replaced by single resistor. These two resistors and these two resistors all are replaced by single resistor. This is 25 ohm, this is 50 ohm, 50 ohm, right? Already we know that we are having total 4 nodes, right? That is A, assume this resistor, assume this as a resistor 2 ohm. Next, this is B, this has 8. Next, this is C, this is D, right? Now see here, this point is C, this point is D. This is C point, this is D point, right? In between C and D, 15 plus 10, 25 ohm is connected, right? That means this is 25. Next, this is D, this is also same as C, right? That means again in between C to D, 50 ohm. This 50 ohm will be like this. This is another resistor. Next, first one is 25. Next one is 50. Right? Next, another resistor. This is C. This is D, right? 20 plus 30, 50. That means here 50 in parallel with 50. 25. Resultant 25 in parallel with 25. You will get 12.5. 12.5 in series with this 2 ohm. Again in series with 8 ohm. Right? Yes, here 50 in parallel with 50, right? Equal values are connected in parallel. Resultant value is 25. This resultant 25 in parallel with 25. You will get 12.5. Next, all 3 resistors are connected in series. 2 plus 12.5 plus 8. You will get 22.5 is the answer. Okay, in this way we can calculate equivalent resistance between A and B terminals. Okay, next problem, find the equivalent resistance of the circuit shown in figure. Now see here also bridge is balanced. Okay, 1 into 4 is equals to 2 into 2, right? Then no current flowing through the 3 ohm resistor. Okay, then 1 and 2 are connected in series, right? These two values 3 ohm, 2 and 4 are connected in series, right? 6 ohm. Now this resultant 3 ohm in parallel with 6 ohm, 3 in parallel with 6, 3 into 6 by 3 plus 6, you will get 2 ohm, right? This resultant 2 ohm in series with 3 ohm right here. Then the answer is 5 ohm is the answer. Clear? Next, last problem. See here, find the equivalent resistance between these two terminals, right? Here I need to calculate equivalent resistance across these two terminals. That means in this problem, first clearly observe this problem. Here 2R and 2R connected in series. That means this resultant value is 4R. Okay. Next, this R and R are connected in series. resultant value is 2R. This 2R is in parallel with this 2R. Okay, two equal values are connected in parallel, right? 2R in parallel with 2R. When two equal values are connected in parallel, resultant value is half. That means this total resultant value is R. Okay, that means this 3 resistors replaced by a single resistor R. After that, this 4R in parallel with this 4R. Okay, this 4R in parallel with this 4R. Again, two equal values are connected in parallel, right? Then the resultant value of these resistors will be right. Now the resultant value of these 3 resistors will be 2R. The resultant value of these 3 resistors will be R. After that, this is only single resistor, this is only single resistor, right? That means R in series with 2R, right? That is total is, it is 3R in series with another this 3R, 6R. 6R again in parallel with this 6R, right? The resultant value will be 3R. Okay, in this way we can solve the problems. Okay. Okay, thank you all.